After the domain of the boundary value problem is created, it needs to be discretized so that it can be solved approximately. To start, in the Workbench window, right-click on Mesh and select Properties to open the Properties pane if it's not already open. On the right, change Units to nanometers. This makes it easier to enter mesh sizings later. Next, start the mesher by double-clicking on Mesh in the Workbench window. When the Fluent launcher opens, select Double Precision. This increases both the precision and range of magnitudes that can be represented, but at the cost of using increased memory. Next, under Meshing Processes, change this to match the number of CPU cores on your computer. We can see that Solver Processes is updated as well. This allows for effective parallelization that will improve the meshing and solution time. Once this is set up, click Start to start the Fluent mesher. Once the mesher opens, we can see a series of steps on the left-hand side. We will go through these in order. Start by clicking on Import Geometry. In the bottom left, ensure units are nanometers. This shows that we correctly changed the units in the Properties pane in Workbench. Then, click Import Geometry at the bottom of the screen. Once this is complete, we can see our geometry in the window. This can sometimes take a while, and if the process hangs, it is often worth force quitting Fluent from the Windows Task Manager and starting again. With this complete, click Add Local Sizing in the list. Next to Would you like to add local sizing? Change it to Yes. We can then work to specify the element size for our mesh. First, name this Body Sizing. With the other options left as default, change the target mesh size to 10 nanometers. We can then select the boundaries on which we want to apply this sizing. We will select every boundary except for the one associated with the obstruction, being inlet, outlet, wall inner, and wall outer. And we can then click Add Local Sizing in the bottom. We then want to further refine the mesh near the obstructions, so we can create another local sizing. Name this one OBSTR sizing to stand for obstruction. Again, leave all of the options at their defaults and change the target mesh size to 1 nanometer. This will make the mesh more refined in that region. In the boundaries list, select Wall Pillar and click Add Local Sizing. Next, click Generate Surface Mesh in the list. With all of the options left as default, click Generate Surface Mesh in the bottom left. Once this process completes, we can see our surface mesh in the view. We next need to extend this mesh through the volume of the flow domain. To continue, click Describe Geometry. This presents us with a series of questions that we need to answer so that the mesher understands the flow domain. Under Geometry Type, select the geometry consists of only fluid regions with no voids. Leaving all of the other options at their defaults shown here, click Describe Geometry in the bottom left. Next, we want to make sure that Fluent knows which boundary type corresponds to each of the boundaries we created during the geometry step. This influences how the mesh is created. Click Update Boundaries in the list. Ensure that Inlet is set to Velocity Inlet and Outlet is set to Pressure Outlet. All of the remaining boundaries can be set to Wall. With these correct, click Update Boundaries. Similarly, click Update Regions. And ensure that Solid is set to a region type of fluid. And click Update Regions. We can then work to ensure our mesh can capture the boundary layer development in our flow. This means placing uniform elements near the walls of our geometry. In the list, click Add Boundary Layers. In the bottom left, name this Boundary Sizing. Ensure that Offset Method Type is set to Smooth Transition, and change the number of layers to 5. This means that the mesher will add 5 layers of elements near the outer and inner walls, as well as around the obstruction. We can then click Add Boundary Layers. Finally, we can create a full mesh through the volume of our geometry. Click Generate Volume Mesh in the list. Using the default options, click Generate Volume Mesh in the bottom left. Once this process completes, we can see our mesh in the view. If it is not already selected, check the Insert Clipping Planes box in the top bar to see the inside of our geometry. This shows that the elements extend into the interior of the part. The solver will find values of the primary unknowns at the center of each of these cells. Zooming in and looking near the edges of the inner and outer walls, we can see the 5 layers of elements on either surface that will help to capture the development of the boundary layers. Before we move to the next step, it is good practice to check to make sure our mesh is sufficient to get good results. To do this, click Check in the top bar and select Perform Mesh Check. We can see that this is completed in the console, and we get no errors, so our mesh is sufficient to get good results. With this completed, we can close the mesher. Back in Workbench, make sure to save your project.